we've started our study of calculus. We're beginning here with a review of some common functions, common function characteristics. What we're going to do in the next several videos is talk about or show you some functions you should know well and be able to sketch quickly. All of these functions you could look up in your previous algebra books or your pre-calculus books to find more extensive definitions of, but this will be kind of a brief review. Now notice here I drive this just by these questions. Functions you should know well and be able to sketch. So here we start off with a set of lines, right? Y is linear. Linear meaning this is the power of 1 up here. Power of 1, right? This is to the first power. Now let's look at this. We've got y equals 3x plus 5. What does this tell us? Well, the slope is 3 and the intercept is 5. So when I say sketch, I don't necessarily mean a great, something to scale that's going to take a long time, but I want to know where the intercepts are, and I want to know the relationship between these curves. This will help you a lot as you do calculus problems. Again, you'll be drawing tangent lines all the time, so you use linear approximations too to approximate functions. Anyway, let's start drawing this first one. We got what? 1, 2, 3, 4, 5. So we can see how this goes. 3x plus 5, and it has a slope of 3, which I'm going to kind of guesstimate as this. I guess when x is equal to minus 5/3, guesstimate here a little bit. Okay, this is what we'll call maybe y1. Okay, intercepts 5, slope is 3. Again, when we take derivatives, I'll ask you the question on slope like 50 different ways in calculus. Here we got a line that has a slope of 1/3. It's not as steep, much flatter. It's got an intercept of 2. I guess I could change colors. Let's see. I don't have that many colors, unfortunately. I need to maybe figure out how to get more colors. I got a blue line here, 2, and it's 1/3, so that means I have to go out to minus 6 before I 3, 4. So actually, I guess here, this is going to be this would be y2. Okay. Now what happens? I got a negative slope. Negative slope here. Again, we'll go back, I guess, to red. Red should be, again, review here, -2, a slope of -2. And I'm going to have an intercept of 0. And at -1, I'm at 2. I'm guessing where these, I'm not trying to act like they intersect properly at all. I haven't scaled anything. I'm not doing a scaled drawing. But again, I see the relationship of these things. Now, I can't emphasize to you, you need to know, properties of lines. If I have 2 lines that are parallel, for instance, parallel lines, these things have the same slope, right? What's another property of lines? These are kind of things you should know. If 2 lines intersect, these are perpendicular, for instance. These are perpendicular, and this is M4. That's the slope of this line, and this is M5. You should know that M4 times M5 is equal to -1. We'll use that when we find a normal line and a tangent line. Okay, and again, we use lines for linear approximations. Okay, another set of functions. We should recognize power functions here. I got 3 functions up here, x squared. I got x squared, 5x squared, x squared over 3. Okay, what does x squared look like? Well, this is, again, a quadratic or a parabolic shape. You could study all kinds of things about parabolas as you did in Algebra 2. What does the 5x do? 5x. 5x is going to make this thing come up faster, right? If I put in 1 here, 1 on this curve is what? Well, it's 1, 1. But if I put it on 5, it's 1, 5. So it's still parabolic in nature, but it's narrower, or it's been kind of amplified. This is, again, 5x squared. What happens in red? What happens if we, instead of amplify it by 5, we attenuate it? This thing is kind of like saying it's 1/3, right? X squared. Well, 1/3 means at 1, this thing is sitting at 1/3. Now, again, this is an even function, right? That's another reason I knew how to draw it as an even function, x squared. So that property helped me, but at 1/3, it's going to be broader. I know it's even, so if I was perfect, or if I probably could do this in this tool. I could take this line and reflect it. But this curve right here would then be what? 1/3 x squared. Again, you need to understand what these scale factors do to a power function. You need to understand it's real. What might be some other things Okay, back to sketching functions. Here I've got one function here where the first one I call y1. y1 I'm indicating just a difference from y2. Again, I hope you do understand my notation. Here I've got a negative x squared. So let's just look at this. First of all, I've multiplied by negative x squared, and let's just see what that would do. This function here, again in a sketch, this could be minus x squared. Minus x squared. Well, what happens when I put a plus 5? Okay, if I want to add 5 to it, then I'm going to add 5 to it to every point. So I'd go up to 5, and I would basically look something like this. So for every turn here, this distance would be a plus 5. This would be, what's that point going to be? 0, 5. So this function right here is going to be minus x squared plus 5. The negative that reflected it, that reflected it, you know, it turned it upside down. The plus 5 smoothed everything up. Everything up. Okay, well, can we do the same thing? Maybe that's this one here. What about this? I guess I should erase this. My eraser's getting. Let's see if I can. Okay, good. Now I get minus x cubed plus. See, I put the plus 3 in here, and what that means, wherever there's an x, I put plus 3. That's actually going to shift everything to the left. So from here, you know, from this, what did that do? This is minus x squared, right? And if I shift everything over this way, if I put in at negative 3, this is negative 3, 0. Okay, so now this curve here, this curve is going to be minus x plus 3 squared. It's called a translation. Remember, I've just translated it to the left. But now what do I got? Well, I got a plus 2. So I got to bring that guy back up. So then I'm going to bring it up by 2. And so now I'm up, say, 1, 2 here. So then that just moved it up by plus 2. So now this sketch here is minus x plus 3 squared plus 2. That is my new, maybe I'd call that f of x. Now notice I wrote it in such a way that I could see the translation really easily. If the problem could have looked like this, f of x could be, it could be x squared plus, what is it, 6x plus 9. Oops. Negative that, and plus 2. So it could have looked like plus 2, sorry, plus 2. So what would that be? It could be minus x squared minus 6x minus 7. That would also be that curve. I wrote it like this so you could see the translation to the left by 3, and then move it up by 2. I might have turned off my recording there. I'm not sure, so I'm going to summarize what I did. I was working on this problem here in case I didn't capture that. This did what? I took my, I translated to the left by -3. I moved it to the left by 3 units, and I moved it up by 2 units. And you could see it because it was written that way, but I could have just as easily gave you the problem like this, and then you would have had to been able to factor it to find this. Not that I typically do that, but again, you could rewrite that in that regard, and then you can quickly get a sketch. Anyway, thank you. We'll get on with another sketch in the next video.